At exactly the predicted moment, a 40-foot-long, 4-ton piece of metal that had been silently drifting through space for a year and a half slammed into the far side of the moon at more than 5,400 miles per hour, kicking up a plume of pulverized rock and dust that telescopes on the other side of the planet were specifically positioned and waiting to catch. And astronomers halfway around the world had been waiting for this exact collision for months. Telescopes pointed. And ready, because for once, humanity actually knew precisely when and where a piece of space debris was going to hit another world. And if you've seen headlines calling this a SpaceX lunar lander crash, I want to actually correct that framing before we go any further, because the real story is both more accurate and, in some ways, more interesting than that description suggests. Say, let's start with exactly what actually happened, and more importantly, what didn't. Because getting this right matters. No lunar lander crashed into the moon in this specific story. What actually happened involves the leftover upper stage of a SpaceX Falcon 9 rocket, the spent, empty second stage booster, not a spacecraft designed to carry anything or land anywhere, and understanding that distinction is genuinely important because it changes what this story is actually about. So let's rewind to where this all began. On January 15th, 2025, a SpaceX Falcon 9 rocket lifted off from Kennedy Space Center in Cape Canaveral, Florida, carrying 2 separate, genuinely real lunar landers as its payload: Firefly Aerospace's Blue Ghost lander, built for a private U.S. company, and iSpace's Resilience lander, built for a private Japanese company. And this was a shared ride mission, meaning both landers hitched a ride together on the same rocket to save on launch costs. And the Falcon 9's upper stage did exactly the job it was supposed to do. It carried both landers up and set them on a precise trajectory toward the moon. And once that job was complete, the upper stage's role in the mission was technically finished. And here's where the story of the 2 actual landers themselves briefly needs its own explanation, because their outcomes were genuinely different from each other, and that difference matters for understanding the full picture. Firefly's Blue Ghost lander went on to make a fully successful touchdown on the moon on March 2nd, 2025, near a volcanic feature called Mons Latrelle, becoming one of the first private, commercially built spacecraft to ever achieve a fully successful lunar landing, a genuinely historic achievement worth appreciating on its own. While iSpace's Resilience lander, unfortunately, did not have the same success, crashing during its own separate landing attempt. And I want to be genuinely clear about this specific point, because it's exactly where a lot of the confusion driving misleading headlines like this video's title actually originates. That Resilience lander crash happened back in 2025 as its own separate, distinct event during its own landing attempt. And it has absolutely nothing to do with the story we're actually here to talk about today. So with both of those genuinely separate lander stories now understood, let's get back to the actual subject of this video, the Falcon 9's leftover upper stage. And here's exactly what happened to it after its job delivering the 2 landers was complete. Most rocket upper stages, once they've finished their job, are specifically designed to either burn up safely in Earth's atmosphere on their way back down, or get deliberately directed into a stable, harmless disposal orbit. But this specific upper stage ended up in a genuinely unusual situation because it had needed extra thrust to get both landers onto a precise trajectory toward the moon. It ended up in what SpaceX itself described as a kind of orbital limbo, not quite falling back to Earth the way most spent stages do, but also not on any kind of deliberately planned trajectory either, and for reasons that aren't entirely clear even to the experts tracking it, this specific stage managed to avoid re-entering Earth's atmosphere on its subsequent close approaches, instead drifting gradually closer and closer to the moon over time. And this is where things get genuinely interesting from a purely scientific tracking perspective. Because on April 29th, 2026, an astronomer named Bill Gray, who specializes in tracking exactly this kind of leftover space debris, first calculated and predicted that this specific piece of rocket hardware was on a collision course with the moon. And remarkably, he was able to predict not just that it would eventually hit, but the precise date and time the impact would actually occur. And I think that specific detail is genuinely worth sitting with for a moment, because it represents something we, honestly, haven't been able to do very often throughout the history of spaceflight: predict months in advance, with real precision, exactly when and where a specific piece of space debris was going to strike another celestial body. And it's worth understanding a bit about how an astronomer actually manages to make this kind of precise prediction, because it's a genuinely impressive feat of orbital mechanics. Tracking a small, tumbling, uncontrolled piece of rocket hardware drifting through space requires repeatedly observing its exact position over time, feeding those observations into detailed gravitational models accounting for the pull of Earth, the moon, and even subtle effects like sunlight pressure gently pushing against the object's surface, and running those calculations forward to project where the object's path will eventually intersect with another body. And astronomers, specializing in this kind of debris tracking, like Bill Gray, have built increasingly sophisticated tools over the years, specifically to refine these predictions as more observational data comes in gradually, narrowing down the uncertainty in both timing and impact location the closer the actual predicted event gets. And that prediction held up remarkably well. On Wednesday, August 5th, 2026, the Falcon 9 upper stage struck the moon's far side, traveling at more than 5,400 miles per hour, exactly as predicted, and NASA's Juliana Scheeman, speaking for SpaceX, was direct and clear about one specific point worth including here. This collision was not deliberate or planned by the company in any way. It was the unintended result of that specific stage ending up in an unusual, unplanned orbit after the R completing its actual job. And SpaceX has stated it's actively working together with NASA specifically to prevent this kind of unplanned situation from happening again with future missions. And I think that context genuinely matters for understanding the story accurately. This wasn't a controlled experiment or a deliberate operation. It was leftover space hardware that ended up somewhere nobody had actually intended it to go, and I want to walk through exactly how. Scientists actually confirmed this impact happened because the detection process itself is genuinely fascinating and worth understanding properly. Nobody actually witnessed the collision directly in real time. The moon's far side, where the impact occurred, faces permanently away from Earth, meaning no telescope on our planet could have possibly observed the actual moment of impact, even if conditions had been otherwise perfect. But astronomers had a specific backup plan ready. A telescope located in Chile was positioned and ready to watch for something else entirely. The debris plume, a cloud of dust, rock, and pulverized lunar surface material that a collision at that kind of speed would inevitably throw upward and outward from the impact site. And that telescope did successfully spot exactly what astronomers identified as the debris plume resulting from the crash, confirming the impact had genuinely occurred essentially right on schedule. And Carl Schmidt, an astronomer at Boston University whose team was involved in these observations, described himself as, in his own words, 100% certain that what his team had observed were genuine signs of the predicted lunar impact. And I think that level of confidence from a scientist specifically trained to be appropriately cautious about this kind of claim tells you something meaningful about just how solid this particular piece of evidence actually was. And here's where the story becomes genuinely visually compelling too. And because confirming the plume was really just the first piece of evidence, scientists still needed direct visual confirmation of the actual impact site itself, the crater. The collision would have inevitably carved into the lunar surface, and that visual confirmation has started arriving remarkably quickly. South Korea's own lunar orbiter, part of the country's growing lunar exploration program, happened to be well positioned near the moon at exactly the right time, and it became one of the very first spacecraft to actually capture images of the impact site, returning satellite imagery showing exactly what scientists had expected to find. And researchers had specifically predicted, before the impact even happened, that a collision of this particular size and speed would create a crater roughly 60 feet wide and about 12 feet deep, throwing a visible plume of pulverized rock and dust outward from the impact point. And it's worth understanding why an impact like this creates a crater so much larger than the object itself, since a 40-foot-long rocket stage producing a 60-foot-wide crater might initially seem like a fairly modest difference. But the actual physics involved are considerably more dramatic than that comparison suggests. An object traveling at over 5,400 miles per hour carries an enormous amount of kinetic energy. And when it strikes a solid surface at that speed, that energy releases almost instantaneously, vaporizing and violently displacing surrounding material far beyond the simple physical dimensions of the object that caused the impact. And this effect is considerably more pronounced on the moon specifically than it would be on Earth. Precisely because the moon has no meaningful atmosphere to help slow an incoming object down or disperse the resulting energy before impact, meaning essentially all of that kinetic energy transfers directly and violently into the lunar surface itself. And the images that have come back genuinely appear to confirm a new crater matching very closely with those original predictions, and NASA's own Lunar Reconnaissance Orbiter, a spacecraft specifically dedicated to continuously mapping the lunar surface in extraordinary detail, is expected to fly directly over the crash site within the coming days as well. And once that happens, scientists anticipate getting even more detailed, higher resolution photographs of the exact crater this impact actually created, giving researchers a genuinely comprehensive, multi-source picture of the entire event. And I want to spend a moment on why an event like this, despite being a genuinely unintentional accident, actually carries real, meaningful scientific value rather than simply being a minor curiosity or an embarrassing mishap. And I think that's honestly one of the more interesting angles of this entire story. Scientists studying planetary surfaces have historically relied heavily on modeling and predicting exactly how impact craters form, since impact cratering is one of the single most fundamental geological processes shaping essentially every solid surface across our entire solar system, the Moon, Mars, Mercury, countless asteroids, and having a rare, precisely known, precisely timed impact event like this one, where researchers know the exact mass, exact velocity, and exact impact angle of the object involved well in advance, gives scientists something genuinely valuable. A real-world verifiable calibration point they can use to test and refine their existing models of impact cratering more broadly, comparing their predictions, made in advance, against the actual, physically observed outcome once it happens. And that kind of calibration data is honestly difficult to come by in almost any other way, since natural asteroid and meteor impacts obviously can't be predicted with anywhere near this level of precision in advance. And I think it's also genuinely worth understanding that humanity depositing objects on the lunar surface, whether intentionally or, as in this specific case, unintentionally, is actually a considerably longer, more established practice than a lot of people realize. This specific event wasn't remotely the first time an artificial, human-made object has ended up crashing into the moon. That history actually stretches all the way back to September 13th, 1959, when the Soviet Union's Luna 2 spacecraft completed a 36-hour journey from Earth and performed what was, at the time, a fully deliberate, intentional crash landing on the lunar surface, specifically between two lunar regions, known as the Sea of Rains and the Sea of Serenity, becoming the very first human-made object to ever actually reach the surface of another celestial body in history. And in the decades since that historic first impact, numerous other spent rocket stages, decommissioned spacecraft, and various other pieces of space hardware from multiple different countries and space programs have ended up on the lunar surface too, some through deliberate planned disposal, and others, like this most recent SpaceX Falcon 9 upper stage, through unplanned accidental trajectories that simply happened to intersect with the moon over time. And it's genuinely worth mentioning a few other notable examples along the way. NASA's own Apollo program deliberately crashed several spent rocket stages into the moon during the 1960s, and 1970s specifically, to generate artificial impacts that seismometers left behind by astronauts could detect and measure, helping scientists study the moon's internal structure. And more recently, in 2009, NASA deliberately crashed a spacecraft called L-Cross into a permanently shadowed crater near the lunar South Pole, specifically to search for water ice, an intentional impact that ended up providing genuinely significant scientific evidence confirming the presence of water ice on the moon. And China's Chang'e program has also left multiple spent rocket stages on trajectories that eventually resulted in lunar impacts over the years. So this most recent SpaceX event, while unplanned, is genuinely part of a much longer ongoing pattern involving multiple different countries and space programs. And I think understanding that longer historical context genuinely helps put this specific event into proper, accurate perspective. This is a genuinely interesting, scientifically useful moment worth learning about and getting excited over, but it's also part of a considerably longer, ongoing pattern of humanity's expanding presence around and near the moon, rather than some kind of unprecedented first ever occurrence. And I want to spend a moment addressing why this specific kind of unplanned space debris situation is actually becoming an increasingly important, actively discussed topic across the entire space industry right now. Because this isn't purely a SpaceX-specific story either, as more countries and more private companies continue launching more missions toward the moon. And the number of active and planned lunar missions has been increasing dramatically in recent years, with multiple countries and companies planning robotic missions, and eventually renewed crewed missions, all converging on roughly the same general lunar region around the South Pole specifically. The broader question of how to responsibly manage spent rocket stages, decommissioned spacecraft, and other leftover space hardware becomes an increasingly serious, practical concern rather than a purely theoretical one. And this is exactly the kind of situation that space agencies and private companies alike are now being pushed to think more carefully and proactively about. SpaceX's own stated commitment to work with NASA specifically on preventing similar unplanned lunar impacts going forward reflects that broader, genuinely growing industry-wide awareness that as lunar activity continues accelerating, this kind of unplanned mishap becomes both more likely to happen again if left unaddressed, and genuinely more consequential too, since a moon with active surface infrastructure, planned crewed bases, and other spacecraft operating on or near its surface needs considerably more careful, deliberate space traffic management than a moon that's simply an empty, uninhabited target sitting quietly in the sky. And this concern carries particular weight right now, specifically because NASA's Artemis program is actively working toward returning astronauts to the lunar surface for the first time since the 1970s, with an increasing number of robotic precursor missions from multiple countries and private companies already landing in and around the same general south polar region being targeted for future crewed exploration, meaning the overall volume of hardware operating on and around the moon is only going to keep increasing from here, and establishing genuinely reliable norms and practices now, while the moon still has relatively little active infrastructure to worry about protecting, is considerably easier and safer than trying to retroactively impose that same kind of careful coordination once a permanently crewed lunar base and multiple active spacecraft are all operating in the same general vicinity simultaneously. And I think that's genuinely one of the more forward-looking, practically important takeaways from this entire story. And I want to close by bringing this all the way back to correcting exactly what this video's original headline actually got wrong, and being genuinely precise about the accurate version instead. No SpaceX lunar lander crashed into the moon. Both of the actual lunar landers launched on this specific January 2025 mission had their own separate, independent outcomes, entirely unrelated to this specific story. Firefly's Blue Ghost achieved a genuinely successful, historic lunar landing, and iSpace's Resilience unfortunately crashed during its own separate landing attempt. Back in 2025, what actually happened? More than a year later, on August 5th, 2026, was the completely unintended, unplanned impact of that mission's leftover Falcon 9 rocket upper stage, a piece of spent launch hardware rather than any kind of functioning spacecraft, striking the moon's far side after drifting through an unusual, unplanned orbit for roughly 18 months, an event that was actually predicted with genuine precision, months in advance by an astronomer, specifically tracking this kind of space debris, confirmed through both a directly observed debris plume and, very recently, actual satellite imagery of the resulting impact crater itself, with even more detailed photographs still expected from NASA's Lunar Reconnaissance Orbiter within the coming days. And this event, while genuinely unintentional and not something SpaceX planned or wanted to happen, has nonetheless provided scientists with a genuinely rare, valuable, precisely documented natural experiment in impact cratering, adding real, useful data to our broader understanding of exactly how these kinds of collisions physically reshape planetary surfaces, and I think that's honestly a considerably more interesting, more accurate, and more scientifically substantive story than a simple, misleading claim about a lunar lander crashing ever could be. If this helped you understand the real, complete, and accurate story behind this event instead of a misleading headline, hit subscribe, because we're going to keep breaking down real space news clearly and accurately, correcting the confusing or misleading parts along the way every single time. See you in the next one.